Good day, babies! Welcome back to Baby Math Notes. You might try to learn mathematics with the aid of this channel. But don't forget to like, subscribe, and hit the notification bell so you will be updated for our new notes. Today we are going to discuss the first principle of finite induction. So what is the first principle of finite induction? Let P of n be a statement about a positive integer n with the following properties. Number 1, if P of 1 is true. Number 2, if P of k is true, then P of k plus 1 is also true. Then, P of n is true for all positive integer n is greater than or equal to 1. But take note, the first principle of finite induction is also called the weak induction. So if we have an example like this, here is the proof. Ganito tayo gagawa ng proof niya. So here are the steps that we need to consider. Step number 1 is the basis step. In this step, we verify that the statement holds for some values of n. So kahit isang value lang, okay na yun. And then number 2, the inductive step. In this step, we formulate the inductive hypothesis. And then step number 3, we are going to show that if P of k is true, then P of k plus 1 is also true when n is equal to k. So, if all the parts of the first principle of finite induction hold, then we can now conclude that P of n holds for all positive integer n. So, let us start. In this example, we define P of n to be the statement 1 times 2 plus 2 times 3 and so on. And as you can see, meron tayo ditong formula. Ito yung formula niya. Paano ba siya nakuha? Bakit ba siya true? So, ito, if we let n is equal to 1. So, 1 times, di ba ito, kapag 1 siya, so magiging 1 plus 1. Magiging ito na ito nga sa loob. So, 1 times 2. So, kaya dito meron siyang 1 times 2. Yung kada term, ayan o, pansinin mo. So, kapag 2 naman yung n natin, 2. Yung nasa loob, ilan? 2 plus 1 is 3. So, kaya ganito yung sunod na term. Okay ba tayo doon? So, mahalaga na alam ninyo yung left hand side, tapos yung right hand side natin. Okay? So, let us start with the basis step. So, sabi dito, kailangan nating i-verify kung tama ba or kung true ba kapag nag-substitute tayo ng 1 sa n. Kailangan maging equal yung left-hand side natin, ito, dun sa right-hand side natin. Okay? So, let us start. So, if we let n is equal to 1, ito yung left-hand side natin, ito yung right-hand side. Kapag pinalitan natin yan ng 1, yung mga n na yan, nilagyan na natin dito, 1, ayun. And then ito, syempre, kapag nilagyan natin ng 1, yung n dito sa left-hand side, dapat yung sa right-hand side, lagyan din natin. So, ayan. And then, ano nang mangyayari? Ito magiging 1 times 2. So, ayun. And then ito, 1 times 2 times 3. So, ayun na siya. Over 3. Now, 1 times 2 is 2. And then, itong numerator natin, it will become 6. Yung denominator natin ay 3. So, 6 divided by 3 is 2. So, as you can see, yung left-hand side natin, tapos yung right-hand side natin ay equal. So, P of 1 is true. Kasi diba, kung maalala nyo kanina, dun sa condition ng first principle natin, kailangan yung P of 1 natin ay true. Now, our step number 2 is the inductive step. So, sabi dito, in this step, we formulate the inductive hypothesis. So, we will assume that the statement is true for n is equal to k. Kung kanina, we let n is equal to 1. Ngayon naman, si n natin, gagawin natin k. So, thus, we assume that, ayan, kung mapapansin ninyo, di ba ito yung given natin? Ayan, o, n. Papalitan lang natin yung n ng k. Ayan. So, this will be our inductive hypothesis. Then, our third step is to show that if P of k is true, then P of k plus 1 is also true when n is equal to k. we will show that the statement is true for n is equal to k plus 1. So, kung kanina, nag-n is equal to 1 tayo, nag-n is equal to k tayo, ngayon naman, we will let n is equal to k plus 1. So, that is, we show that, ayan, naging ganito na siya. So, k times k plus 1, and then, k plus 1 times k plus 2. So, itong mga n dito, ginawa na natin k plus 1. Kaya, naging ganito. Ito yung kailangan nating i-prove mamaya. Dapat ganito yung maging equal kapag sinolve na natin siya. Pag nagawa na tayo ng proof. Okay? So, kailangan true yan kapag ang n natin ay k plus 1. Yan yung kailangan nating makuha mamaya. So, itong statement na ito. So, kung mapapansin ninyo, ayan, as you can see, kanina ganito lang. Ito lang siya. Ngayon, meron ng k plus 1 times k plus 2. Which is, pareho lang din naman. Kanina, if we let n is equal to k, ganito yung naglabas. Which is true, kahit na mag-substitute tayo dyan ng value ni k. Okay, ganyan pa rin yung term niya. And then ito, since naging k plus 1 tayo, syempre ito, magiging k plus 1 yung nasa labas. And then yung nasa loob, kapag ang k natin ay k plus 1, magiging k plus 2 na siya. Okay? Kaya naging ganito yung term niya. Okay? So, here is the proof. Kung mapapansin ninyo, ito yung equation natin nung sinubstitute natin ng k sa value ng n. Ayan. And then, if we let n is equal to k plus 1, ganito na yung left-hand side natin. Itong right-hand side natin, yung galing kay k ito, copy lang yan natin. And then, ang pagkakaiba lang nila, itong sa left-hand side, meron kang k plus 1 times k plus 2 na nadagdag. O, nung sinubstitute natin yung k sa n, andito siya. Ayan. And then yung right-hand side natin, ayan siya. Ang nangyari lang, nadagdagan ng k plus 1 at k plus 2. So, kung meron tayo niyan dito sa left-hand side, kailangan sa right-hand side, meron din tayo. Okay? Now, apply simple algebra. Ayan, magsasolve lang kayo ng fractions. Ayan, so, syempre, ang LCD natin is 3. So, ito na yung nangyari. Pag sinolve natin yung fraction na yan. And then, ito, bakit ba si k plus 1 nasa labas? Kasi, yung k plus 1 na yan, ang common dun sa numerator. So, kapag inilabas natin si k plus 1 dito, ayan, since yun ang common din sa two terms, ang matitira na lang dito ay k saka k plus 2. Kaya, ayan. Plus, so, inilabas din natin yung k plus 1 dito. Ang matitira na lang ay 3 times k plus 2. So, meron pa tayong continuation. Let us continue. Ayan. So, ano bang nangyari nung paglabas ng common factor nila? So, syempre, itong nasa bracket natin, yan na agad ang una nating isosolve. So, apply a distributive property, k times k is k squared, k times positive 2 is positive 2k, plus 3k, plus 6. Ganun lang yun, distribute lang. So, ganito na yung itsura ng sagot natin. Pero take note, we can still combine like terms. Ayan, pwede natin itong pagsamahin. It will become what? So, k plus 1 times k squared plus 5k plus 6. And we all know na itong quadratic term na ito, or quadratic expression na ito, ay pwede pa nating i-factor out. Ano ba yung factors niya? So, we have k plus 2 and k plus 3. So, ito yung nakuha natin. Ito yung kailangan nating ipakita, which is, naipakita natin. So, we show that if p of k is true, then p of k plus 1 is also true when n is equal to k. Yung kaninang step number 3 natin, yun yung sagot na nakuha natin. Na equal sila for n is equal to k plus 1. Yun lang yung goal. So, therefore, by the principle of finite induction, yung given natin, ayan, naipakita natin na this is true for every integer n is greater than or equal to 1. So, kung may makikita kayo dito, may maliit dito na square, ayan, ibig sabihin lang niya na tapos na yung proof natin. Great job, babies! Don't forget to like, subscribe, and hit the notification bell
so you will be updated for our new notes. See you on our next Baby Month notes.